Visioned. All right. So let's see what we're trying to fill in on this. The second screen, it says this. Trying to find where are the 4 methods that we're looking for here. Okay, oh, is it?
They're in the instructions on the right-hand side.
Is it further down there? I thought it was in the notes.
Way up top, like second paragraph, maybe.
Let's see. Oh, there we go. Okay, it's not called out as a separate line. Okay, so here's the 4 that we're trying to do. Now, of course, you can't just read the instructions for the exact values that you need. What you're going to need is you're going to need to go to the Vault documentation, which I'll just say, see if I can't get us straight there. Yeah, so here's auth methods. And over here, we'll go through our list of auth methods. Let's see, we want app role, we want Kubernetes, GitHub, and Azure. So Azure is there, GitHub is there, and Kubernetes is there. So we're going to be building this list based on these 4 auth methods, and it's going to be the name of the auth method that Vault uses. So the string that we need is basically this here. It's the auth method name within Vault. And yeah, see, it's called out here in the Vault documentation, the Azure auth method, the GitHub auth method, the Kubernetes, you just looking at those gray shaded strings, and it's pretty obvious. I think there's no real surprises there. So allowed methods, we're going to say Azure, and then app role. Oops, app role. GitHub, and Kubernetes. Okay. Then we want to save that. And let's see here. There were some, let me hop the instructions over here for a bit. What's the other thing we need to fill in here? Was that it? Let's see if that's it. Oh, resource type. Okay, I thought I saw that. All right, so let's pop that down. And pop this over. Okay, so where is resource type? Find, plan, find resources, resource type. Now let me see where that is. Auth methods, Vault. What we may want here find resources. What is the resource type for a Vault auth method? It's going to be looking at the Terraform Vault provider, which I already have in my history, so we can go take a look at that. And the resource type is Vault auth backend, I believe, is what we need. So let's take a look and see if that's what we need. Vault auth backend. Save that, and let's try it again. Oh, attribute. What's the attribute that we need? Let's see. Oh, okay. The attribute is going to be type. The name of the auth method type. So let's see. Right. And then we need to put a list in here. I can see that. The list name is going to be allowed methods because we already created that up top. Yep. Okay, now let's save that. And we'll try it one more time. Oh, and we got to do our test cases. All right, so now we've completed our policy and let's test it. And it looks like, pop this down so I can see better. It looks like we have passes all around. And we click check and we're all set. Now, I think at this point, we pause there to go back to the content. Is it, I'm looking for assist from people who were here yesterday. Do we want to go ahead and start with chapter 5 at this point?
Yeah, that was the end of the day yesterday.
Okay. All right. Fantastic. All right. So I'll pause there for a second and say, if anybody has any questions, go ahead and put them in the chat. The other thing is I kind of deliberately didn't fill in some things that I knew as I was going along in there, because I wanted to show the idea that if you haven't quite done it all, or you just don't know what you need to do for the next thing, you can just click the check button and it'll actually give you a pretty good hint about the next thing you should do. So if you notice there, when I clicked the check button a couple times, it told me, you know, you haven't done this in angle brackets, you need to replace this thing. So if you're stuck on one of the problems as you go through this, don't worry about it. Just go ahead and click check and it'll give you a hint. And when you fix that and you click check again, it'll give you another hint, and you don't run out of hints. You just keep going until you finish. All right, I'm going to go ahead and go over to the chapter 5 material then. We're complete on chapter 4. Now this is going to be using Sentinel in Terraform Cloud and Terraform Enterprise. And so the idea here is, yeah, you've written a policy, you've tested it with the command line. Now it's time to actually put it into a real Terraform Cloud or Terraform Enterprise environment. And then you also want to test it there. So when you first put these policies in, there's a few things that we recommend that you do. Put each of your new policies into its own policy set and have some test workspaces and use those test workspaces to assign that policy set to. You know, basically just to make sure that you don't have test policies potentially affecting real infrastructure that you are managing with Terraform. The other thing is to set the policy enforcement level to hard mandatory, just so that you don't have a bunch of queued up runs that you have to dispose of before you can try to do another test. And then you create these policies. The preferred method to create these, I believe we still have the direct policy method in Terraform Cloud, but it's strongly deprecated because it will go away eventually. What you want to do is you want to add your policy code to a VCS repo, a GitHub repo or a GitLab repo, or even Bitbucket or Azure DevOps, whatever you're using for your version control. You're going to add them to a repo in your version control system. Make sure that each policy set has the policies and the Sentinel config file that defines the enforcement of that policy. And they can be in any directory, and you can configure the policy set in the Terraform Cloud user interface. And when you're in that user interface, you can give it the repository, but you can also give it, if you have multiple policies in different directories of one repo, you can define which specific directory each policy set should be taken from as you define that policy set. And you can even have them live on separate branches if you want. I have seen that workflow. It's not as common as the path-based configuration. You can give them parameters, and you can then, the last thing you do is determine for this policy set, which workspaces should you actually apply this policy set to. And this is kind of an example of what that GUI looks like. I'm not going to go over this in detail because it's just basically a visual of what I just told you. But you can see here, the main important thing is that your policy set source is a VCS repo. Typically what you'll have a private repo that your policy sets will come from usually. And so what you'll see there will be some version of a private custom OAuth application. It'll say, you know, GitHub Enterprise or Bitbucket Enterprise or whatever it is. I see somebody ask, can we have more than one configuration file for a policy set? You can only, to the best of my knowledge, you can only have one Sentinel HCL file that defines the behavior of that policy set. And you can only have one configuration for it in Terraform Cloud. Now, that said, because you can specify parameters for a policy set, you can use the same code to create multiple policy sets, I believe, and give them different parameters. And then the different parameters could influence what they're enforcing or how they're enforcing it. And then now down here, this is the other thing that's worth calling out, is this says, then I believe it's the default, policy enforced on all workspaces. What you're going to want to do when you're testing, and probably in production as well, is say policies enforced on selected workspaces, and then you'll apply it to specific ones. And of course, in the beginning, the ones you're going to apply it to are just going to be those test workspaces that you have. And then once you're satisfied that it's behaving properly, you'll go on and continue to apply it to other production workspaces. So this is an example policy set. This is the configuration for the sentinel.hcl file. And so this is defining the modules that this policy set will use, and then it defines the specific policy enforcement. And so you can see there's the source, which is the actual .sentinel file that defines the individual policy, and that's coupled with an enforcement level of soft mandatory. And one of the nice things about that is that you can take the same policy, and instead of needing to modify the policy file to change its enforcement level, the policy file itself stays the same. You just change the enforcement level attribute in the Sentinel policy set config, and you don't need to change the policy file to either increase or decrease that enforcement level. So this is an example of a Sentinel policy that fails. This was a hard failure, so you cannot apply this run. And if you look at the output, this is what that failure output will look like. You'll see that it's going to tell you what policy failed and what the enforcement level is, so you can kind of get an idea of why it failed. And then it also says this AWS instance has an instance type that is not in the allowed list. You know, somebody might say, well, why wouldn't you allow micro if you allow a small? You might not allow a micro because a micro is too small to do whatever that workspace is there to do. So it's just pointless to provision a T2 micro. That's a question that I've seen people ask, is like, well, why wouldn't you allow people to provision a smaller instance? You maybe don't want them to provision an instance that is so small that it's useless. But in any case, it doesn't really matter why. What matters is that there was a defined list of instance types, and somebody tried to provision an instance with a type that's not in that allowed list, and so you get this failure. Now this policy check passed, you still don't have an applied run, because this was, I'm going to guess, a soft, or not a soft mandatory. This was in a workspace that does not have automatic applies configured. And so the policy check passed, but the apply was still queued waiting for approval. And then you can see right there that our colleague Roger Berlin discarded that run because he was presumably just testing this policy. And this is what a pass output looks like. So then you've tested your policy with the command line. You've tested your policy in Terraform Cloud. How do you get it out to your actual TFC organizations You definitely want it in a policy set because, like I said before, going forward, that's going to be the only way to get policies into Terraform Cloud. You can either add it to an existing policy set or you can create a brand new one. And the difference between the two is if you have an existing policy set that this policy is basically an add-on to, and that policy set is already applied to the workspaces you want the new policy to apply to, the easy thing is just to add that policy to a policy set that's essentially already deployed. So you still want to test it in its own policy set, but then when you're actually going to deploy it to your production workspaces, you add it to the already deployed policy set, and then it automatically starts being applied everywhere. Add the parameters that it needs, add any references to any Sentinel modules that the policies in it use, because your new policy may use a module that if you're adding it to existing policy set, the existing policy set may not have a module that your new policy uses. Is there a way to nest policy sets? I don't know off the top of my head if there is. I'll throw that out for the other TAs. All right. While they're thinking about that, I'm just going to keep going. Oh, that's the end of chapter 5. Okay, so we're actually good with chapter 5. And then somebody fill me in. Are we kicking out to lab, or do we want to continue with chapter 5 at this point?
Amit, I think that question may have been directed to you.
Yeah, I think we're ready for the labs. The
Okay.
rooms are ready, and I'm just going to open up the rooms right now.
Okay, fantastic. Then everybody enjoy working on exercise 2A, and your TAs will be in your breakout rooms. And if you have any questions, you can ask them. And if it's something that goes beyond their knowledge, back to us. So enjoy, and we'll see you back here when the breakout rooms conclude.
Everyone, welcome back from the various labs. Thank you so much again. My name is Fraser Pollock. I was your previous teacher, and now I'm returning back to finish off this next chapter. So Joe Thomas was kind enough to cover chapter 5 with us. So you learned how to deploy a policy into TFC or TFE, and you went through the secondary lab learning how to manage your additional policies. Next, we're going to be discussing some Sentinel language advanced concepts. This chapter is incredibly dense, and it is sort of a replication of the documentation. So don't worry if you don't get all of this information down. This is provided as a reference information as follow-up later. But regardless, we'll get kicked off here. We're going to talk a little bit more about the actual structure of the Sentinel language and some of the capabilities that it provides. So first up, a couple of the key language construct. So there are going to be 5 principles we're going through here. They are how the language is structured, some of the more advanced consumptions and features and capabilities, and then each of the sort of core definitions. If you're using these documentation as a reference, at the end of this chapter, there is the reference documentation, so you can click through the various links there and learn some of the capabilities yourself as well. So at the very beginning of your Sentinel training, we taught you a little bit about how structuring Sentinel happens. So we have our imports. Those are the key things that we're going to bring into the Sentinel policy. Then we typically have our search or evaluation criteria, followed by the actual test, and then finally a set of main functions or validations. So now we're going to go through each of these in a little bit more depth and talk about their actual core value, their core structure. So Boolean expressions, I'm sure everybody's familiar with this from a programming language. It's just an evaluation of a true or a false. Typically, the way that we use this in Sentinel is validating whether or not a resource is in an allowed list or in a denied list. Rules are the way of validating or results of calculating a function. So remember, we have one main rule, which is the super rule. And that sort of overrides all existing rules. And then you could have as many sub rules underneath that as you wish. They typically follow an and or construct, and you can provide your own customized logic on top of that if you wish. So there's an and or function inside of the Sentinel language, and you can nest and structure as many rules as you would like to on top of that. Statements, functions, and variables we've talked about a little bit in previous chapters. They are the ability to execute procedural logic. Functions are the reusable bits of code, the reusable libraries, and there are some available on the internet that you can start to get used. And the variables, that's the ability to store rules and functions as a particular name. So remember, in our very first example yesterday, we talked about a find all resources, and that find all resource was the variable name, and that was taking the function and putting all of the data into that variable. And then finally, your parameters to customize your policies. Next up, we're going to talk about a couple of the different types of functions and variable constructs inside of Sentinel. So all of the types of variables are probably ones you're familiar with in programming languages: Boolean, integer, float, string, list, map. The only differentiator here is a list is a collection of 0 or many items, and a map is a collection of 0 or many key pairs. So in this particular instance, if you wanted to collect all of your resource attributes, that would likely be a list. If you wanted to collect all of the names of the resources with their attributes, that would be a map. We talked a little bit about the abilities to do operational validation. So you've experimented a little bit with this as you've gone through the labs. The very first one you did was checking whether or not an engine was in a supported list when you were validating your Vault engines. We've also done a couple of for loops behind the scene where we're going through all of the list of resources and validating those. And then we also briefly talked about filters. That's the ability for you to get a subset of a collection. So either through some form of regex or searching a function. And imports we've already discussed in a lot of depth. We'll skip over pre-declared. Sentinel keywords. As with all programming languages, there's a couple words that are no-nos, ones that are reserved by the actual core programming language that you cannot use. They're all available here. I generally keep these as a reference on my desktop when I'm going through and writing my Sentinel policies. So this is your first time going through your Sentinel policies. I would generally recommend that you keep this around. They're all the common words that you'd probably be familiar with in programming languages. The only ones I would extend is some of the Sentinel specific ones, such as func. Numeric and logical operators. So this is your logic gates. So validation of individual functions. So you have your arithmetic operators, you have your logical operators. Note that when you are structuring your rules, remember you have one main rule and that can evaluate only to true or false, but each rule within there can also validate to true or false. So you have the ability to validate whether or not at least one of them must be true or as many of them as quantifiable can be true inside of your logical set. So let's say, for example, what's a good example? Maybe RAM and CPU specification. You would want to validate that either a certain amount of RAM is not being used and or an expensive CPU is being used. So validating exactly one of these must be true. Validating that they either have the right T2 microset or right image type set and or they've specified manually some sort of override. Comparison operators, we'll make sure that this is just sent out. I don't think everybody's going to memorize this, but common JSON operators equals, greater, and less than. Most importantly is probably Sentinel's short circuit logic. So for compound Boolean expressions or when you're evaluating the logic, Sentinel does not validate all conditions further. It only knows the final answer. So when you're structuring your rule set, it's very important to follow the full structure of your rule set. And the best way to accomplish this is, and we'll talk about in the following chapters, is to go through a print and statement loop. So this print and statement loop essentially allows you to evaluate individual rules, see the expected results from them, and then you can go on and add additional rules as necessary. If you're looking at the high level structure of your Sentinel rules and you validated that, yes, this image is in the support type, but no, the user is overriding that and specifying some additional configuration that you don't like. Validating that each of the individual statements is correct is important when evaluating the logical structure of your Sentinel policies. Matches. Matches are incredibly important. When we talked about at the very beginning, if you build something in Terraform, it very likely has a native Sentinel resource to validate it. There's also the ability to just generically evaluate something in Sentinel. And that's generally used with the matches operator. So at a high level, if we have an existing resource that is in a supported type, you can likely use a native function. However, if there are resources outside of there, you have the ability to just do a direct string import. And this string import is subtly very strong. What it essentially allows you to do is any customized resource, any customized variable, any customized value that you import into the system, we could just do a regex against it. So rather than doing a native function or a native call to get the resource, instead we just directly import the string, the holistic string, and validate the string. So let's say, for example, we're configuring a brand new cloud that the company is using that nobody else is using. It's called Nimbus Cloud. And Nimbus Cloud has a couple of new types that we want to validate, flat, tall, and small. And we want to validate that only customers are using the small instance. Now, there may not be a supported resource import for that yet. There may not be a way to validate that resource yet, but I could just import the string and do a regex against that and validate it in that way. Similarly, if you have custom strings inside of your organization, such as business units, organizational cost metrics, other custom tags that are required, this is a fantastic way to validate those as well. Else operator. So we've had a lot of questions about how do I do this for everything but this one? This is typically the best way that this is accomplished. Rather than individually assigning Sentinel policies on a group level and then picking out the policies that are not affected, the most effective way to do this is to add a tag and then exclude that tag. So in this particular example, you would allow the memory configuration on all of these, except and or if one of these has a tag that it is accepted, for example. So anytime you're managing exceptions, an else operator is incredibly powerful. So it's a really easy way to do everything but this one exception that's existing inside of the logical structure. Most importantly, too, it's also a great way to validate that there are no results. So if there's ever a situation where you're trying to avoid a null or you are struggling to get results, you could also do an else, and this will invert your function and give you a result no matter what. Sentinel for loops. So for loops are incredibly important. Not only is it a way to fill a map in a list by going through all of the resources and grabbing the various attributes that you want to evaluate against, but it also acts as a keyword to define one or two iterative variables. So let's say, for example, we're going through a list of virtual machines. We would like to grab all of their names, and we would like to also collect the business unit that tag that is attached to it. So for every resource that's built, we want to get a full inventory of their tags that are associated with those as well. This allows you to iterate through this for loop in a recursive fashion until complete. And once this is done iterating, the variable is assigned to the key and the second variable is assigned to the value. So it's a really good way to fill up that scenario. Other ways that customers use this is by populating their CMDB, for example. So let's say, for example, you want to just use Sentinel in an auditory fashion. You don't want to do a soft positive or a soft negative. You don't want to do a hard negative where you slap the end user. You just want to do a logging. How many people are doing this slightly undesirable behavior in my organization? This is a really great way to start grabbing or proactively monitoring behavior with Sentinel. Filter and map, we've talked about if and case statements. So case statements are probably one of the most important functions and the most common that you're going to be using. Case statements allows you to process and validate any value that comes back from a variable. So in this particular example, we're doing a store that's open and closed on Saturday, but it's really easy to turn this into a practical example. Let's say for our organization, we prefer that provisioning on Saturday and Sunday needs a specific approval process. Let's say that provisioning before 9 a.m. and after 5 p.m. needs a specific approval process or needs an additional level of approval. So we could do a very simple case where we validate the day or the time that something is being provisioned in the organization and validate that that is either going through the normal process or requires the additional approval. So there's a lot of very unique ways to use case validation inside of Sentinel, specifically with Terraform. Now, that was a very dense chapter focused primarily on the capabilities and functionalities. There's no review for this chapter, but as always, the reference slides are included at the end of the chapter. We're going to transition back into labs now. So I believe we are on, and anybody correct me if I'm wrong, we're on lab 3 now. If for whatever reason your lab has timed out, or as you were going through it, you failed a lab or were unable to complete it, I'm going to copy and paste a special command in the chat just to jump you ahead. If you do this on any lab and then click check, it will automatically complete that lab for you. So we're going back into our individual breakout rooms now. We are proceeding on chapter 3. Oh, sorry, correct me. I was corrected. We're on 2B right now. So we're going on to 2B. And then let's go all the way to 3, and then we'll take a break after this particular chapter.
Hi, everyone. Hope you had a really good experience with the labs. I believe that Joe is going to be taking over for the remainder of the training. Over to you, Joe.
All right, fantastic. Well, let me share my screen again. Now we're going to get into advanced Sentinel techniques. I don't know about anybody else, but I always feel like what we've seen already is pretty advanced so far. This is the one where I go, wait, this is advanced. Let me get a refill on my coffee cup because I'm going to need it. When you're debugging policies, and you will have to debug policies, the errors that you'll get from Sentinel tend to be fairly generic by default. It's going to just usually give you a message like that, like an error occurred at this, point in this line, column 10 of line 34. Well, that doesn't necessarily actually tell you what went wrong. And also the problem that caused that could have taken place earlier in your code. And what you're seeing is the point where the cascading failure finally turned into an error. Some of those are just simple things, missing punctuation, you left off a brace. It's the kind of stuff I do all the time. You might have other errors that are because of things like you checked for an attribute, but it isn't there. And so you get an error because you are checking for a thing that doesn't exist. So that's where you need to add checks for, is this null, or just say, if this is empty or null, we're going to make it be null. I believe there was an example of that in 2B where you had to do that. The other thing is, just like with almost any programming language, you can explicitly print things. You can even print an entire object, a resource object, so that you can go, well, wait a minute, this code should do the thing against this resource, but maybe the resource isn't formatted like you expected. And so if you print that resource, then you can get a better idea of maybe why your policy code isn't parsing that resource the way that you thought. Checking for missing expressions. There are different definitions of missing. This is kind of, harks back to the old debate in the database world of, is null the same thing as being empty? And there are people who will say it should be the same, and there are people who will say, no, those are two completely different conditions. Sentinel is flexible enough that you can essentially treat those two things the same, or you can treat them differently depending on what your code is doing. You can have empty strings, you can have empty maps, empty lists, you can have null, which means that that value simply isn't even there. Or no, if it's absent, it's undefined. If it's there, but it's not set to anything, it's null. And then there's a couple of expressions here. I don't expect anybody to necessarily, fully understand these at first glance. I can tell you for sure that I did not, especially that second one. That's the kind of thing that I sit there and I go, let me put that into a text editor and reformat it across multiple lines and sit there and stare at it for a while. But the basic idea here is you have options for how you deal with these different cases, and you can deal with multiple different cases using the same technique by using these compound expressions to say, okay, in this case, if it's null or an empty string, I want to do this thing. For something else, you can say, if it's null, it's an empty string, it's an empty map, it's an empty list. If it's anything like that, I want to do something to it. And then the length function can only be applied to strings, maps, and lists. So you need to make sure that you check the type before you try to get a length of something that you can't get a length of. Restricting multiple attributes. There's a couple of different ways to do this. And I think the way that it's done in most of the example policies that you'll see in our example policy repo is you multiple filter functions, and then you check the length of all the lists that they return. And when they say multiple filter functions, these are the ones that you've probably seen at this point already, where it checks for something and then adds to an array if it finds an error. And so then if you get to the end of the filter function and the length of the error array is 0, then everything passed. If the length of the error array is not 0, then you have an error that you need to fail the policy on, maybe output some kind of diagnostic info to say why the policy failed. The other thing you can do is you can also just write a custom function that tests all of the attributes for each resource while iterating over the resources just one time. And in that case, to be able to distinguish between what part of your policy failed or what attribute failed when you checked it, you want to return some kind of a map with a representation of each attribute and whether it passed or failed. And then filter functions, validation functions, etc., should all be called before the main rule, so that basically the main rule, the only thing it will usually do, or almost the only thing, will be to evaluate the length of these error lists and then either pass or fail the policy. And that's so that you don't end up with just pages and pages and pages of Sentinel output, and you can just output error messages of your own where you think they need to be. Making calls to external API endpoints. Now, I'm going to preface this by saying, yes, you can do this. In fact, there are a lot of cases where you want to do this because you want to make a policy decision based on some external factor. My favorite example of that I've used in previous versions of this class is you can have a Sentinel policy that allows or denies an apply based on the current temperature. You could say, no, it's too hot outside to do that, or it's too cold outside to do that, to allow that to happen. I can't imagine why you would do that. I mean, I could probably make up some kind of contrived scenario, but yeah, you could do that if you needed to. So yeah, you can make an arbitrary HTTP endpoint call. That can be either a get or a post. And if it's a get call, then you can put query parameters into the URL itself, but that's very insecure. You can also put query parameter, you can put data into the headers and send those custom headers. There are limits on the size of those headers. Most of the time, what you'll probably be doing, except for the very simplest cases, is putting stuff into a post body and then sending that post body as part of the HTTP call. There's supposed to be a link there where it says some example policies that use the HTTP import are here. That link didn't make it when these slides got converted from one format to another. So I actually went back and found that link, which I will paste in the chat here momentarily. And I believe everybody should be able to see that now in the chat. One thing I'll caution you on with the HTTP import is occasionally you see people say, well, oh, wait a minute, I can actually make Sentinel do things itself and not just query things. Yes, you can do that. I would strongly caution you against doing that, because then conceptually you are evaluating conditions while you're changing conditions, and maybe you're not changing conditions that you think are going to influence how your policy evaluates, but you could be without realizing it in some cases. So I always advocate that when people use the HTTP import, that you do it in a way that you are not changing things, you are merely reading data from some API endpoint. Sometimes people think that they're going to have Sentinel do stuff on the back end, and that's maybe a bridge too far. But that is the end of chapter 7. If there are any questions about any of that, feel free to drop them in the chat. I think we'll probably give it a minute or two if anybody has any questions about that. And then we have our, I believe it's our last breakout of the day to go with the rest of the labs.
Okay, the breakout rooms will be opening up shortly.